Hey everyone, so in the last video we talked about logistic regressions, and in this video we're going to talk about how to run the logistic regression test in SAS Jump. We're not going to worry about graphing logistic regressions because that gets very complicated in Excel. So I'll teach you at the end of this talk about how to state your results statement for this. So what we're looking at here is my Excel file, and I'm looking this time at ginseng leaf area and its effect on reproduction. So I actually work with American ginseng as in my research, in my PhD research, so I thought it'd be fun to throw a little bit in here. So what I'm wanting to know is, um, does ginseng leaf area have an effect on whether an individual is reproductive or not reproductive? All right. So the first thing I'm going to do is open SAS Jump and open a new data table, just like we've been doing. And of course, I'm going to open my logistic regression and I'm going to import this data. Now, like we've been doing every other time, we want to double check that SAS Jump has labeled our data appropriately. So we know that ginseng leaf area is a continuous data type, and in fact, it's our continuous independent variable. So we look over here and we see that yes, SAS Jump has labeled ginseng as continuous, as you can see by that little blue triangle. We also want to look at reproductive status. So for logistic regression, of course, we have nominal dependent variables. So we want to make sure that SAS Jump has labeled our dependent variable, reproductive status, as a nominal data type. And in fact, it has. And we can see that by the red histogram. Okay. So one thing that's kind of funky whenever you're working with logistic regressions in SAS Jump is the fact that we have the opportunity to really decide which which reproductive status is our reference, or the thing that is a success to us. And a success to me would be the ginseng being reproductive. So if I double click on the header and I go to column properties and then down to value ordering, we see that SAS Jump specifies the order in which we want our data to appear by whatever is the first letter or number or any type of entry in our spreadsheet. So what's most interesting to me and what I think of as a success in this experiment would be a reproductive status of reproductive, yes. So I'm going to move the Y up. And all this is going to do is specify that Y is going to come before N, yes before no, in my output. So I'll push apply and I'll push OK. Now in order to actually run the logistic regression, we're going to go to Analyze, Fit Model. And you have to be a little careful because we're so used to using, nominal, independent, and continuous dependent variables, but we're not doing that with logistic regression. So we know that our dependent variable is nominal, and we're going to cast that into the window under Y, our dependent variable. And our ginseng leaf area, we're going to add to model effects because that is our X variable, our independent variable. And you see up here under personality, it's going to run a nominal logistic regression for us. So that's good. That's what we want. All right, and here is our output. Here's what we've got from SAS Jump, and you can see here that it's listing reproductive first, which is what I requested it to do in the original data table. So just like with a regression or a correlation or anything else, before we even make any inferences at all about our results, we want to look at our test statistic and our p-value. So in order to find that on this logistic regression output, we go down to parameter estimates. So parameter estimates. And just like with the regression, we're going to look at estimates for our independent variable, ginseng leaf area. And what we find is our test statistic is now a chi-square, and the probability greater than chi-square is our p-value, and that's what we use to interpret our test. So we have a p-value of 0.0007. What does that mean? Well, it's less than 0.05, which means we can reject our null hypothesis. So we say that the slope does not equal 0. So based on those results, I could say something like ginseng leaf area has an effect on individual reproduction. But I want to know a little more than that. I want to give this test some direction. I want to know how ginseng leaf area is affecting reproduction. And to do that, I go back and I look at my logistic plot. So what we have here is basically ginseng leaf area increasing in size along the x-axis, and then we have reproductive, no on top, yes on bottom. So you can tell by this figure that as ginseng leaf area increases, the probability of being reproductive, which is under this area, increases as well. So one really cool thing you can do is click on this little cursor on top, and you then can click on your regression line, and we can see that, for example, for a ginseng that has a leaf area of 400, I was close to 400, we actually see that the probability of being reproductive is 93.7%. Conversely, if we go down here and we look at a ginseng plant with a leaf area of 50 centimeters squared, there's only a 2% chance that that plant's reproductive. So it's really cool to follow this along. I get a kick out of it. So at 250 centimeters squared leaf area, we see that there's about a 50% chance of being reproductive. So this is really neat. I really enjoy playing with these figures, but what would we do for a results statement for logistic regression? Well, let me get out my pen and paper, or pen and tablet, I guess we'll say, and I'll show you exactly what you should do for this results statement. So we would say that the probability of being reproductive increases or increased as leaf area, and I'll just put centimeters squared, why not, increased. And we know that because if we go back to our figure, we see that as ginseng leaf area is increasing, as it's moving to the right on the x-axis, our logistic regression is increasing. So we're having a higher probability of being reproductive. So I'm also just going to add to this a little parenthetic statement, logistic regression Then I'm going to put my chi-square value. It's a little squiggly x. And that was, we'll go down here and look again, 11.46. And our p-value was, down here again, 0.0007. And that would be the results statement for my logistic regression. Keep in mind, however, we don't always have to use yes or no statements, yes or no dependent variables. We can use survived and died. We can use got a disease, did not get a disease. Any categorical data type, any nominal data type we could use. So I hope this helps. Like I said, we're not going to be graphing this one, but that's a strong way to state your results for any papers or presentations you might have to do. So moving on to the next couple of videos, we're going to start talking about our very last statistical test in that bestiary graph that we've been drawing. So I look forward to that. I'll see you then.